Hey everyone, welcome to another deep dive. Today, super cool, kind of last minute guest. I have with me Ryan from Oho Network.
Yeah, happy to be here.
So cool. Um, yeah, we'd love to kind of hear how Oho got started. What was sort of what sort of drove, Oho into kind of creating oracles, and how did you guys kind of get started, if you know it?
Yeah, so actually me and my founder Laws, we were both at basically this got started when we were working at Umi. So Umi, for anyone unfamiliar, is a DeFi lending protocol on Cosmos. And yeah, basically we were working on their Oracle module for basically their lending protocol. And eventually it just ended up, offshooting into why don't we actually just make this our own, Cosmos SDK chain? Basically its own, sovereign Oracle for providing Oracle services to any other protocol that wants to, that wants to integrate with us. Obviously, the initial or the first obvious one would be other, Cosmos SDK chains for integrating with us, but now it's sort of expanded into um, this whole other thing now where EVM chains can essentially integrate with us through the XLR bridge. And we're soon to be a Celestia rollup. So basically other Celestia L2s that, have the Celestia DA as their, under them essentially can get prices from us as well.
Super cool. Yeah, we'll have to go into kind of how the various pieces work kind of after
Yeah.
we, yeah. I think
Yeah.
each one could probably be a deep dive or a
Mhm.
repo. But yeah, I guess how does your Oracle work? So let's say your, you know, I'm guessing there's or I'll just let you explain. Then you can kind of walk me through if
Yeah.
you want to, you have it's a Tendermint chain, so you have the validators, and what do they do?
Yeah. So, um, yeah, let's start with what we have initially, because I kind of jumped ahead and I'm saying that, that we're a Celestia roll kit. That's
Yeah.
essentially what we're about to be, like, currently working on it. But let's start with the, I guess, original architecture and then sort of work our way towards that. So yeah, you can think about it. Just Oho itself is just a Cosmos SDK based chain. So we have a set of validators that are essentially voting on prices to post onto our Oracle, onto our chain. Basically, the way that they're voting on these prices is through um, basically a sidecar process off chain that's called a price feeder. And that price feed is essentially reaching out to different price providers like Coinbase, Binance. So those are some of the big exchanges that it reaches out to. But one of the things that actually makes Oho unique is that it also reaches out to indexers that we built in house for more basically smaller cap assets that aren't listed in these big exchanges. A good example is like staking derivatives, so something like SD Osmo, SD Atom. That's directly provided by our Osmosis API, which essentially reaches out to the Osmosis chain for that pricing data directly. So we have certain in-house built APIs separate from the more established, more common APIs you'd use for Oracle solutions like a Coinbase, a Binance, and whatnot. And these are all getting reached out through by our price feeders, and these price feeders are essentially aggregating all of that price information. Basically taking the medians and basically spinning out a USD conversion of all those assets that it's asked to essentially get. And then that's getting fed into each validator that's then essentially placing votes for the prices of assets that's it's essentially required to vote on. So we have basically parameters set through governance for what assets each validator has to vote on. And yeah, the way it's doing that is essentially through that sidecar process that I mentioned, the price feeder, which feeds at these prices. So that's essentially how, um, that's essentially the first step of this whole system is how the prices actually go from, these different price providers onto our OHO blockchain.
Okay, so to kind of slow it down a little bit, you'd kind of said that so each validator is responsible for a specific set of prices, or it's kind of like I'm guessing what you have like 100 validators or
No, no. So they're all responsible for the same type of prices.
okay.
It's just the assets that they're required to vote on are essentially set by the network through governance.
Oh, okay. So like you'd say like the network is going to do Bitcoin, ETH, USD, ST Osmos, and then we vote on how many prices can you guys do?
Exactly. Yeah. So it's basically stuff set by governance to make sure that each validator is providing the price data that the network requires of it.
So and then they would basically run this sidecar that it's similar to like they maintain a database of the median of all these prices across these exchanges. And then whenever a transaction comes in, so do users have to request the data or does it just sort of do you guys post it every block?
No, so yeah, this is the aspect of the actual OHO blockchain is getting price updates every what we call vote period. So this
Okay.
is ranging a couple blocks for essentially verifying the voting process and making sure that we tally up all the different votes coming from validators. But to jump ahead kind of a little bit, part of what's basically what we're doing with our Celestia rollup is we're now going to integrate essentially our OHO chain or what's going to be our OHO rollup with ABCI++, which essentially allows us to kind of chuck the whole architecture of having to have the price feeder as like a sidecar process. Essentially, within each block, validators can take that pricing information and essentially vote, through ABCI++. So this is all built in with the newest version of the Cosmos SDK already.
Yep.
Basically, what price a certain asset is going to be. So it can happen. One, it can happen each block, and two, it doesn't require an actual like extra sidecar processing happening. It's going to be actually built in within the OHO node itself.
Yeah, so this is basically like in a Cosmos block to kind of explain for people. There would be like the pre-commit phase over here where validators all sort of check off on a given block, and then down, or that would be like the pre-vote, and then there's what the commit phase or pre-commit phase, and
It's,
then this would be, I guess, where they would all the validators would then put in their prices, right? They would
yeah, yeah,
throw in a bunch of prices here, and then it would go and basically be finalized into a block. Um,
exactly. Yeah.
and then I'm guessing you take the median of the prices, so all the validators put on Bitcoin, and then you would take the median, and that's like the official OHO price, right? Or
Yeah, essentially. I mean, it has to basically fall under a certain like standard deviation that the validators are all kind of voting on.
okay,
Um, uh, yeah, it's the median of the different essentially price providers that it's getting because typically an asset's going to have more than one price provider, except for like I mentioned, the very
right,
like small cap like staking derivatives where there really only is one source you can get.
right.
But for other assets, it's typically going to be a median of different providers.
Well, it's a median of different providers, but then do all the validators have to agree on what the price was? Like, because like there would probably be like if you have 100 validators and they all are within 10 cents of each other, is that
Yeah. Yes.
and
So
then
it has to fall within a certain like deviation threshold, essentially.
okay, cool. Um, yeah, and is that a governance thing as far as what the threshold is, or
Deviation threshold, yeah. So we do have quite recently actually it used to be just a simple like price feeder config, but now it's actually something that it's a governance parameter and it's actually per asset. So certain
okay,
assets that tend to have a little bit more swing and we're sort of okay with allowing that. You can actually adjust it to have a little bit more deviation for the more smaller cap assets.
yeah, that's super
But
cool, nice. And then okay, so now let's get to well, I guess before we get to how we bridge or use this data outside,
Yeah.
like, are these guys, I guess, how would you slash them? Do you have disputes on there, or is it sort of just a governance slower slashing?
It is, yeah, governance set as far as, we have different slashing windows as far as like how long, a certain validator hasn't put in a vote. Um, I can't remember off the top of my head like what those numbers are, but yeah, it's again just it's another governance parameter that's essentially dictating, um, how often a validator has to be putting in votes to, still be part of our network and not get slashed or jailed. Um, and yeah, basically how often they have to do that.
Yeah, this was a discussion I had. I recently I just talked with the Slinky team.
Mhm.
They're doing something similar with as far as um, validators being oracles, but the question I had for them was basically like, so will the chain halt if, like, let's say the Bitcoin price goes both ways, one up on Coinbase, down on Binance, and the validators have no idea what the right price is because it threw. Um, would they just not submit for Bitcoin that block, and then the chain would continue to kind of just grab the other prices?
Yeah, I guess in the case of something like um so I mean I think it's one of the reasons why we like enforcing provider minimums for each
Yeah,
price. So typically it's three providers. And the reason for that is, yeah, we um you shouldn't, up to a certain point, you shouldn't start seeing those crazy swings across multiple providers, especially if it's for very huge
for
like
sure.
market cap assets like Bitcoin is, um, especially. So, yeah, I think it's just, yeah, mainly uh, we try to do it through an enforcement of um, basically having a good amount of price providers at a given point, so that different type of doomsday scenarios like that are, very unlikely to happen, if at all.
Okay, cool. Yeah, no, that's well, I know, like, as you were saying, for like the lower market cap ones, it's always like much more of a risk because you have like, like we deal with that with like Steth, like it's like 97% on curve. It's like, well, what do you
Yeah,
do? What do you do if the API goes down? It's like there's not much you can do. So,
yeah.
so
So, yeah, I mean, as far as like risky assets like that, I mean, one thing we also do provide um, is historical data for all these
okay.
different assets. So basically, historical prices back to a certain point, as well as medians of those prices. And where that's typically useful is for basically protocols that are using this Oracle pricing data. When it comes to small cap assets, it's very easy to um, influence the price of those assets basically from big whales just, manipulating the price on, different markets, just because there's just not a lot of liquidity in those assets in the first place. So one way is that, historical data and median data like that helps is, other chains that integrate with us can essentially use that median or historical price data for decisions on their protocol, rather than just the raw price at a given moment. Because that with more riskier assets that can be manipulated quite easily. So that's one, I guess, safety mechanism
So
against
do
that
you
is
post that with
having.
every price update? You post like historical prices as well, or is that just something else that they can request?
Yeah, no, it's posted on our Oracle module every. We have a specific like stamp period as far as I can't remember how many blocks it is now, but let's say it's every 30 minutes. Stamp the current price of this asset, and that'll go back up to a certain amount of stamps, and then we'll prune um, any stamps that are older than that. Again, these are all governance parameters.
Nice. Did I miss anything about how the Oracle works? What would be?
Um, No, yeah, I think that this was a pretty good deep dive, and at least this portion of it.
Yeah.
Um, yeah, I guess the important thing is, yeah, like at the exact moment we're using that price feeder sidecar, but very soon this is all going to be done in a per block basis with ABCI++.
Yeah. Well, and then Okay, now walk me through. So like, okay, so you finalize this, you finalize a block on your network or a series of blocks with prices. When do you post them to Celestia? And what is this going to look like?
Yeah, so essentially, our OHO chain is going to become a Celestia L2. So
Okay.
essentially, every block, a sequencer is going to be posting, um, yeah, basically our block information and block data onto the Celestia DA layer. And this will happen every block. So in theory, other Celestia L2s can even basically can interact with the Celestia DA layer and have our pricing data as well.
Well, I mean, so I know Celestia is what, 12 seconds blocks? Um, I guess
I
how fast,
believe,
or sorry.
yeah, I believe it's pretty customizable as far as the actual L2 that's
Yep.
um, posting um, that data. So um, from what I've been told, I mean, it can actually be done in like the data aggregation can be done in like milliseconds.
Okay. Well, this was what I'd always wondered, like, for like an L2 Oracle, if you post your data on Celestia here, and if it's like, if Celestia blocks are finalized every 12 seconds, but you guys are much faster, like, when do you consider the Oracle data finalized for like a user purpose would be the question.
Yeah, I guess if you're querying, the yeah, if you're getting it from the DA layer specifically, then yeah, it probably is bottlenecked by however fast that DA layer is. That being said, I mean, one of the ways that we um, ascend, one of the ways that we relay assets to EVM chain again is through Axelar, and that's usually done through IBC, which is coming directly from the OHO chain. So in that case, it's actually querying the OHO chain through an IBC transaction, and that's essentially sending that data to the Axelar bridge. So in that case, actually, I think it's really um, up to the block speed of the OHO network.
Right. So just real fast, like I think most people are familiar relatively with IBC's a light client bridge. Is Axelar sort of similar? I don't know enough about the Axelar network. If you,
Yeah, Axelar is so it's actually they're their own Cosmos SDK network themselves.
okay,
And what they essentially allow you to do is by setting up an IBC handler on your chain for transfer message, you can essentially send data through an IBC memo um, through the Axelar chain, and they essentially handle posting that data to an EVM contract on whichever destination
nice.
chain that you're trying to send that data to. The only limitations there is that it is essentially EVM chains that are supported by Axelar, which in the case of testnets and mainnets is really
Most big
you
ones.
know, yeah, most big EVM, L1s and L2s.
Super cool.
And also, actually, you can do messages with the other Cosmos chains as well, theoretically,
Just via
and
IBC.
CosmWasm contracts. Yeah, yeah. Mhm.
Yeah. Well, I'm guessing that's probably what you guys had done so far for Umi, right? It would just be use just via IBC, right? That would be the way to go.
Yeah, I will. So when we started Umi, yeah, we were just an Oracle module on Umi itself.
Okay.
But then, yeah, once we had spin out to our own chain, yeah, it was basically through IBC. Yeah, that's another interesting. Um, Now that we've integrated with Axelar, that could change is so basically the way that we would, currently and previously send price data to other Cosmos changes or basically other CosmWasm contracts is through relayers that essentially run on our chain. And well, not run on our chain, sorry, run on the destination Cosmos chain that it wants to post on the contract to. And basically just query OHO nodes for price data and then post the relayer would post it on our CosmWasm contracts on that chain. So it was more of it was pretty much a push, model Oracle
Would these be like
where
trusted roles for the relayers, obviously? Would these be like a trusted relayer role you would give and then
yeah,
like
yeah, we were running the relayers basically in house for
right?
different chains that were requesting our data. So yeah, very much, push based Oracle in that sense. But the interesting thing with Axelar is basically how our EVM construct works is they're pull based. So you send an actual relay request through one of our EVM contracts to then reach out to Axelar, send an IBC transaction to Oho. Oho then essentially does a round trip where it takes the price data inside of the chain and then brings it back to the contract via IBC and Axelar again. So it's round trip, pull based communication. How that affects the CosmWasm stuff is that it can actually, in theory, work the same with CosmWasm contracts. Essentially, yeah, the CosmWasm contracts would essentially request to pull those prices the same way it does from an EVM contract. It'll go through Axelar and IBC. So rather than having to do the what we were doing before with the push-based Oracle system, we can also make those CosmWasm contracts pull-based.
Right. Yeah. I mean, I've heard this before that basically like vanilla IBC communication across chains is relatively slow. So people were building basically routes around this. Is that kind of what you
Mhm.
guys did? And was that sort of the rationale behind it?
No, I mean it doesn't. I don't like this specific um, push towards like pull-based um, CosmWasm. It hasn't. We haven't deployed anything yet. This mainly was just a byproduct of us kind of shifting gears towards EVM and how we ended up, designing our EVM contracts to now that we're, sort of revisiting some of our CosmWasm contracts that we've designed in the past with that relayer. We're just sort of realizing that, yeah, like this doesn't have to be essentially as I don't know what's the right term is, I guess, babysat with, us running our own relayer adaptive post prices. Users can directly just request that price data now pretty much autonomously now that we're, an Axelar integrated chain.
Okay.
So it's less overall, I guess, overhead work from us, well, from having to run a relayer on every chain that we want to post price data to. You can imagine that in the long term, as you add more and more chains, needing to spin up a relayer for every chain you add isn't necessarily a very scalable approach.
Well, I mean, ideally, what you would hope is that like people could just grab the data for themselves and pull it over. This is like I think what the future that I've heard is like pretty soon we're going to have zero knowledge proofs, like zero knowledge light client bridges. So you'll be able to run some zero knowledge proof of your chain and then just pull the Oracle data over, right? Um,
Mm-hmm.
and
Yeah.
then you won't need any sort of push model, but um, the future, I guess. Um,
Yeah.
anyway, on as you guys are using Celestia, do you guys use like a shared sequencer or like are you the sequencer of your your own data, and then how do you sort of see that working out with other L2s, and how do you coordinate with them?
I think at the moment when you're basically going yeah, doing a Celestia L2 through the role, it's single sequencer, I believe, at the moment.
Okay, so are you using like the base sequencer on
Yeah.
Celestia? Okay.
Yeah.
Um, yeah, and then just wondering like how does the chain pay for that? Like did you guys find, because like I know one of the reasons that a lot of people move, one of the proposed reasons that people will move to L2s is like you'll be able to lower your inflation rate that you're paying out to validators, and then you can just basically pay it over to, you know, Celestia or something like that to save money in the long run. Have you guys found that in your analysis, or
So which uh yeah, which part do you mean as far as pay? Like the actual like OHO validators? Like how do they get
Yeah.
paid? Or
Yeah, like I mean,
yeah,
how
so we
do
have
the OHO validators get paid, and then how are you paying for Celestia through any of this?
so we do have um, the OHO token
Yep.
within the actual OHO network. That's is yeah, basically paying out rewards for actually validating price on our chain. Um, that still basically we still don't have a mainnet token out at the moment for that's actually worth actual money. So that's the I guess next step is yeah for onboarding basically external validators is basically once we do our token launch, it's going to be done through the network itself and through um, the reward process that we have within our chain.
Okay. So it would just be straight inflationary rewards to the validators.
Yeah.
And then would you guys use that to also pay to post the data to Celestia? Would that be the idea? Or would this be some other setup?
I believe so. Yeah, I'd have to.
Okay.
I don't have the exact answer actually at the moment, but I'm pretty sure. Yeah.
Yeah. Well, Celestia is like free now anyway, so it's not as big of a
Yeah.
deal. Um,
Yeah.
cool. Yeah, I guess when you do the token, so like what's like do all validators sort of get paid out equally in this model? Because like I know basically every validator is going to have a list of say 100 prices, and they're all going to have to go and post these prices. And will they basically just get paid out equally amongst how they're doing that, or like how will the sort of they compete to be a better? Will they get more if they're the median
Yeah.
or something like that?
Yeah. So we have something in our chain called miscounters. So this is essentially if in a given vote period you miss a price, your miscounter gets incremented. And the way we have it set up is we're essentially going to be rewarding the validators with the lowest miscounters, and that scales um, through logarithmically. I don't have the exact function in my head, but essentially it scales very advantageously for having the least amount of miscounters out of the whole validator set. So yeah, the rewards essentially go down the more your miscounters go up over time.
Okay, cool. And then is there any sort of like I know that this is one thing that some oracles do and others don't. Is there any idea of like hiding the data, like commit reveal schemes to prevent any sort of mirroring or um
Mhm.
yeah.
Yeah, so that's actually how our Oracle works currently. With the price feeder as a sidecar, and then it essentially goes through a pre-commit transaction with the hash that's verified, so that essentially we know that the validator isn't essentially free riding other validators. So it has to go through these multiple steps, which is why the vote period is essentially a multi-block um, process. But that's what's required now without ABCI++. So the idea is ABCI++ should have something similar to that built in, so that each block it's kind of effectively doing the same thing where it goes through that prepare proposal process. Then it does a vote extension. All the validators essentially verify that vote extension, and then finally, if all that passes, that final piece of data is committed into the block.
Yeah, so it's kind of
So yeah, the idea is ABCI++ should kind of take care of that and abstract that away from us. While at the moment we're sort of doing that ourselves.
yeah, so to explain to people watching, like the general idea is like you don't want to commit, you don't want to just say like, hey, I'm reporting Bitcoin is $50,000 because then all the other validators will just copy you. So they won't get slashed if you're the trusted party. So what you do is you submit this hash, and then later like with ABCI++, like later in the same block building process, you'll reveal what it actually is, and they have to match. Whereas
Yeah,
now you would have to do like the first block is submit your hash, second block is do a reveal and go from there. Um,
yeah.
So, I mean, how do you guys think about too, like what is sort of the speed of OHO? And how do you guys think about making this thing faster and versus the risks of making it faster, which was, obviously less you're not able to sort of query as quickly on any of these APIs.
So faster as far as um, like how fast we're posting data. Yeah.
Yeah.
Yeah. I mean, before it was obviously we were constrained by that vote period, right? So like we had initially we had it at 5 blocks. We were able to optimize it down to only be 3 blocks. So that um, yeah, that took us down to maybe like 12 seconds. But the whole, I guess, yeah, appeal of again ABCI plus plus is that if we're able to essentially post this on a per block basis, it's really limited to how fast we can settle blocks. Which with the Celestia L2, I don't have the exact number in my head as far as um, how fast that realistically can be done, but I'm like almost certain it might be less than a second.
Yeah. Well, I think DYDX is using it too, right? So they're definitely under a second.
Yeah.
And
Mhm.
they're crazy. But we can
Yeah.
they work is for a different deep dive. Um, Super cool. Anything anything I sort of missed and anything else you would want to share on how it would work or what other networks it could potentially work with?
No, I mean, I think the only thing we didn't spend that much time in is maybe like the EVM portion with Axelar, but um, that's um, yeah, I mean, it's pretty. The only thing I'd add to that is that one of the cool things we have on our EVM smart contracts is not only is it like a pull based model as far as um, like requesting pricing data, but you can actually call a contract method while getting Oracle price data to use in that contract method, all within the same transaction. And that's something that's essentially possible through Axelar GMP. Is you can essentially encode a function parameter on an EVM contract and request that it gets called with the OHO response data that it gets within that response at once. So, yeah, that's just a cool feature that's also available through our EVM contracts and is essentially um, uh, our main, I guess, value prop as far as um, integrating with our with our EVM contracts is it's as simple as any chain can essentially just import our OHO contract interface within a few lines and then can essentially start calling their own protocol methods using OHO price data through that.
So basically, the Axelar will call your contract and update the price for you, right?
Yeah, so well, it's more like the OHO contract calls the Axelar gateway,
Okay.
which then triggers basically a round trip to OHO and then back to the EVM contract that called it for that price data.
And I'm guessing you'll have to pay gas somehow, so you'll have to fund it.
Yeah, so that's the other sweet thing about Axelar is they have their own like gas service contract that can essentially calculate the whole round trip, and you
Hey,
can pay
Max,
that with
there we go. Do you,
you can pay that with yeah, exactly. You can
yeah.
pay that with the native gas token on whatever EVM chain you're calling from, or basically a list of select ERC20s that are supported as fee tokens on Axelar.
Cool. Yeah, it reminds me, do you remember Oracleize back in the day? I don't know if you had ever used but that was like the original Oracle on the EVM chains, and basically it was like one guy in London running a server, but you would ping it from your smart contracts, and he would call it back with the response. Um,
Uh,
it was just like hard coded in, and it cost like 50 cents, and that was
hey man,
this was the Oracle back in like 2016, and that was what everybody did. So
sounds ahead of his time.
yeah, we're getting back to it.
Yeah, right.
It's all coming full
Uh,
circle here. Um, yeah, no, that's super powerful though. I mean, what's the round trip time usually for Axelar? Like, if you call it? Would it be the next
Yeah.
block usually?
No, I mean that's really the bottleneck
Right.
as far as getting prices um, on EVM at least. So like on the OHO chain again, it's per block. That can be milliseconds. The actual price relay though, I mean, it's probably going to be more in the order of multiple seconds. There's ways leveraging our partnership with Axelar that we can essentially use what they call like express relayers, which can essentially prioritize our transactions so they go through a little faster. But at the end of the day, I mean, um, doing any type of bridging transaction is obviously going to be slower than um, native calls to an L1 blockchain on Cosmos or something like that, especially if the blockchain itself that you're using is already not super quick. Like, if you're using mainnet Ethereum, it's probably going to be slower than um, I don't know, some other like layer two, like Arbitrum or whatnot.
Yeah. No, super true. And then can I ask I guess one maybe a last dish question, but you had said you're using Rollkit. Um and obviously you're on Celestia, like how was that decision process for you guys? What made you pick that versus say IBC Hub or yeah, the Atom Hub or using Ethereum or anything like that?
Yeah, I mean, it's I'm not the one that necessarily makes the business decisions, so it's hard for me
Okay.
to say what the ultimate reason was, but yeah, I imagine um, one of the prime benefits we get from working with Celestia is that by being an L2 on them, our network security is essentially it scales with the size of the Celestia DA network as well as the L2s with it. So our cost of manipulation comes, whatever the cost of manipulation is for Celestia, which is, I think at this point, like it's in the multi billions, like,
Okay.
15 billion or something like that. So I imagine that was a big, um, yeah, that was a big reason for that decision is, yeah, like, integration essentially ultimately leads to that much security right off the box once we're a Celestial L2.
Nice. Um yeah, well thanks for sharing. Is anything else you want to add? Where can people sort of find you guys and what should they know about you?
Yeah, so our Twitter is Oho Network. We post updates about our next developments and how we are along the process, and then our GitHub if anyone wants to look through our code, post an issue, whatever, um, is also Oho Network.
Awesome. Well, Ryan, you did an awesome job considering, like, I think to let people know he jumped on like 10 minutes before the call or something like that. Found out it was going to be you, but thank you very much. And yeah, look forward to talking again.
Yeah, thank you, man. This was awesome.